guys! Welcome back to my YouTube channel. So for today's video, I am going to make a video tutorial wherein I'll be teaching you on how to find an optimal solution of a transportation problem using the Northwest Transportation Method. From the title itself, we will begin solving in the northwest corner or in the upper left-hand corner of the table. Suppose we have a table set up like this. We will begin solving this problem by finding the initial solution. To find the initial solution again, we will start at the northwest corner of the table. After which, we will look at the demand and supply value. We have 200 and 300. Between the two, 200 is the smallest, so we choose 200. Now the demand has been satisfied, so 200 minus 200 is equal to 0. 300 minus 200, we have left with 100. Now we need to move to the next square. We can either move to the right or move down. But here, we can no longer move down since the demand has been satisfied. So therefore, we need to move to the right. At this square again, look at the demand and supply value and choose the smallest. Between 400 and 100 is of course 100. So we choose 100. Now we can see that the supply has been satisfied since 100 minus 100 is 0 and the demand value becomes 300 since 400 minus 100 is 300. And now we need to repeat the process until the supply and the demand has been satisfied. After we solve for the initial solution, now we need to proceed in finding the optimal solution. First step in solving for the optimal solution is to calculate the values for R and K. When you say R, this represents the rows and K represents the column. In solving for all R's and all K's, R1 must be equal to 0. And we will solve the remaining R's and K's by using the formula R plus K is equal to C, wherein C is the transportation cost. Please bear in mind that this formula is only applied for used squares. For example, in this used square, we have 0 plus K1 is equal to 2. So we get K1 is equal to 2. While on this used square, we have 0 plus K2 is equal to 5. Therefore, we have K2 is equal to 5. While on this square, we have R2 plus 5 is equal to 3. Therefore, we have R2 is equal to negative 2. While on here, we have R3 plus 5 is equal to 8. Therefore, we have R3 is equal to 3. Finally, in the last used square, we have 3 plus K3 is equal to 3. Therefore, we have K3 is equal to 0. After calculating all R's and K's, now we are ready to calculate the I, which stands for the improvement index. This has a formula I is equal to C minus R minus K. And this one is only used and applied in the unused squares. For example, in this unused square, we have 9 minus 0 minus 0, so we get the improvement index equal to 9. While on this unused square, we have 7 minus negative 2 minus 2, so we get I equal to 7. Next, here we have 6 minus negative 2 minus 0, we have I is equal to 8. And finally, in the last unused square, we have 4 minus 3 minus 2 is equal to negative 1. Since there exists a negative improvement index or I, the solution is not optimal yet. Therefore, we need to draw a loop. To make a loop, we need to draw a moving rectangle wherein we will land on the used squares that contains value. We will begin by putting a plus sign on this square and then move to the right and make a stop. Put a negative sign. Then now we will go up and make a stop. Put a positive sign. Then we will go to the left and make a stop and then put a negative sign. And then we will go back to our origin and now we draw a loop. Now you look at the loop. Look at the values with negative sign. Between those values, choose the smallest value. So between 200 and 100, the smallest value is 100. So we will use the 100 value. Now, add 100 to the squares with positive sign and subtract 100 to the squares with negative sign. So in this square, we have 0 plus 100. Therefore, we will assign 100 to this square. Next, we have 100 minus 100. So 100 vanishes from that square. Next, we have 100 plus 100, so we will have 200 on this square. And in this square, we have 200 minus 100, so we only got 100 on this square. So now our second table looks like this. And now we will repeat the whole process all over again. So we will begin by assigning r sub 1 equal to 0 and finding all the remaining r's and all the remaining k's. Remember that in solving r's and k's, we need to use the formula r plus k is equal to c and is only applied in the used squares. So these are all r's and k's that we got from the second table. And now we will proceed in solving the improvement index or I, which has a formula of I is equal to C minus R minus K and is only applied in the unused squares. So these are the improvement indices in the second table. And since you can see that all the improvement index are already positive, therefore we got an optimal solution already. And that's all for this video. I hope you learned something for today. See you on my next video tutorial. Thank you. Bye-bye.